Hi, this is James. Welcome to Lab04 Oscillations. The purpose of this experiment is to examine the motion of a spring mass system in which the mass springs in an arc while oscillating on the spring, and some fundamental physics principles involved, including Newton's second law, which states F net equals to dp over dt, and velocity update formula and position update formula, which have appeared in the previous labs, are also going to be used in this lab. And unique to this lab, some forces of interaction, such as the spring force, is being used. So the formula of the spring force is given, and it is equal to minus Ks times S times L hat. L hat is the direction from the stable equilibrium point of the spring towards the motion of the spring. And Ks is the stiffness of the spring, or the spring constant, and S is the displacement change of the spring. And another thing that is very important to cover is the energy principle, and that states the total amount of energy change equals to the respective amount of energy change in each of the following categories: the kinetic energy of the system, the gravitational potential energy of the system, and the spring potential energy of the system. And they're respectively given by the following. And by the parameters given by the video, we can calculate the period t, the stiffness k, and the rest length of the spring appeared in the sample video. And here are some conclusions for the initial conditions. And these data are going to be used later in the GlowScript computational model. Here are the initial conditions shown in the code, including the initial positions and velocity of the mass, the spring inputs, and the energy calculations. And this is the main part, which is the iteration of the code. And within the given time interval, the mass has experienced a set of position and velocity update, and so does the spring, because it is a varying force, and also the energy conditions must be updated as well. And here are the results of this experiment. It can be seen that the blue sphere represents the computational model and its related trajectory, and the red sphere that is going around by itself is the experiment, which is the sample video. It could be seen that although they had the same initial conditions, their trajectories are very different, especially in terms of y position, and that is due to a lot of different errors, including tracker's error and also frictions and drags. So those are going to contribute to the distinction. And in the discussion one, is the energy principle satisfied? And my answer to it is yes, because the sum of all energies is equal to 0. Or in other words, the change in kinetic energy of the system is equivalent to the change in potential energy. And that is the sum of the change in gravitational potential and the change of spring potential. And discussion 2 is about the differences between the time periods calculated respectively from the x and y positions graph. Time period calculated from x and y position graphs are distinct. One is 1.614 seconds, and the other one is 1.488 for y. And the discrepancy mainly comes from, since the motion only happens in a single axis, and that's the x direction, so there's going to be drag and heat loss in terms of x direction, since motion mainly happens there. And that's going to lead to a lower frequency, since it has a lower speed and a longer time period. And that would explain the differences between x and y positions graph, resulting to different time periods.